Okay, so I love this flashlight. It's a Leatherman that they've since discontinued. It's a great little thing. It runs on a single AAA, and it's an LED flashlight. It's really bright, and it has two settings. There's bright and a lower one, right? Now, I noticed something when I was actually taking a leak in the woods. As you can see individual droplets when this thing is on its low setting, and that's because it's using pulse width modulation in order to get a lower LED output. LEDs are really just on and off. There's no volume control, as it were. You can't raise and lower them, and so they get around that by pulsing them on and off really fast. And if this video holds up the way I think it will, you can probably actually see that in this video right now. That flicker of that light is actually that pulse syncing up with the frame rate of my iPhone's camera. So, at any rate, the point. I have a photodiode here, or no, a photoresistor on here, and a little, what do you call it, voltage divider circuit set up, right? And I have a DSO Nano. You point one at the other, and you'll see that thing flicker up and down. There you go. There's your pulses. They are about 10 milliseconds per, well, this is written out 10 milliseconds per div, right? And there's about one per div, so those are about 10 millisecond pulses. And it looks like a sawtooth wave. In reality, on the chip itself, it's probably more like an actual square wave, and the distance between the pulses relates to, you know, kind of the brightness or dimness of the LED. So you'd end up with something like a long trough. I'm trying to draw through the camera here, like that. Or you'd have something like a long pulse with a little trough, right? This would be much brighter than that one, okay? Now, it's sawtooth probably because this photoresistor has some kind of property to it where it drains slowly or something. I can't actually explain that. If somebody wants to take a guess in the comments, go ahead. Anyway, thought that was kind of cool.